So far in Chapter 4, we've been looking at equations of lines in a particular form. That form is sometimes referred to as slope-intercept form, and it's often written as y equals mx plus b. And one thing we haven't talked about is the y and the x are sometimes referred to as the dependent variable and the independent variable. So sometimes we say y depends on x, and the idea here is that if we change the value of x, we're going to get a different value of y. We're sort of plugging in different values of x to generate values of y. So for that reason, we also say y varies as x. And for some linear relations that we look at or that we graph, this makes a lot of sense. If you're graphing, for instance, position versus time, how far you have traveled, whether you're running or driving, is obviously going to depend on how long you've been traveling. And so certainly there, the distance depends on the time. But other linear relations, for instance, the one we looked at with converting from Fahrenheit to Celsius, is it really the case that Fahrenheit depends on Celsius or Celsius depends on Fahrenheit? You could argue both depending on which way you write the equation. So we're going to look at some alternate forms of writing linear relations. And we're going to start by looking at horizontal and vertical lines. So think about a horizontal line. A horizontal line, all the points fall on a horizontal line, obviously, and along that line, the y values are all the same. So this table of values here, 0, 4, 1, 4, 2, 4, 3, 4, we could plot them, and we would get that 0, 4, there's 1, 4, 2, 4, 3, 4, and you can see, those points all fall along that horizontal line. So we could use the same techniques we used in the previous sections to find the equation of this line, and we can say, well, the change in the y is actually 0. We're not increasing or decreasing, and the x is going up by 1, so we can start writing the equation of the line. We can say, well, y is equal to 0x, and obviously 0 times anything is just 0, so to get a y value of 4, you're going to have to add 4 to that. And there's not much point in writing the 0x because 0 just wipes everything out, and so really the equation of this line is just y equals 4. And if you look at that, there's only the one variable, y. So in a sense, there is no relation between the x and the y. We just simply have y equals 4. So regardless of what x is, doesn't matter, y is always going to be equal to 4. And that's really the essence of the equation of a horizontal line. Now, we can use the same idea to understand what's going on with a vertical line. Let's take a look at the table of values on the right. The x values are all the same, 2, and the y values change, negative 1, 0, 1, and 2. So again, the x values don't seem to have any relationship whatsoever with the y values. If we graph this, we can see that we have 2, negative 1 is just a unit below the x-axis, then we're on the x-axis, and then 2, 1, and 2, 2. So they're all falling along that vertical line, and we could continue this very easily. And in the same way that we saw that the horizontal line, the y values are all the same, and so the equation is y equals 4. Here the x values are all the same, and so we can write this as x equal to 2. We can't apply the same sort of techniques of finding the equation of the line that we did for the previous examples. It doesn't work in this case, but we can understand certainly there is no real relationship between the x's and the y's. All that we really know is that every single point has an x value of 2. And so x equal to 2 is the equation for this particular vertical line. And x equal to a number is going to be, in general, the equation of a vertical line. Now, let's take a look at, again, a slightly different example. So in example 2, we have 2x plus 3y equals 6. So this is not written in sort of a more formulaic way where you would have change a value of x and then just plug it in and figure out what y is. Here, regardless of what we choose to do, we're going to have a little bit of work to do. And how do we graph something like this? Well, the easiest way to graph a line is just to find 2 points. All you need are 2 points, and you can draw a line that passes through those 2 points, and you've got the graph of the line. And the easiest 2 points to find, certainly for this form of equation, are the 2 intercepts. In other words, where it crosses through the x-axis, where it crosses through the y-axis. And those happen to correspond to where x is 0 and where y is 0. So let's see what happens if we let x equal to 0. So what we're going to do is we're going to say All right, let's figure out what this equation is if x is equal to 0. So we have 2 times 0 plus 3y is equal to 6. And again, 2 times 0 is just 0. So really this equation simplifies to 3y equal to 6. And if 3y is equal to 6, then y is just equal to 2. So what we've done here is actually we've come up with our first point. So we can make a little t-table, and we can say, well, when x is equal to 0, y is equal to 2. And we've got our first point on our graph as well. So 0, 2 is 2 units above the origin, and that's it right there, 0, 2. Now, what if we do the same, but this time for y? What if we let y equal to 0? So if we let y equal to 0, we have 2x plus 3 times 0 equal to 6. 3 times 0 is just 0, so this simplifies to 2x equal to 6, and that simplifies to x equal to 3. So that gives us our second point and our second row of our t-table. So we have 3, 0. And where is that? Well, that's 3 units to the right of the origin. And so there are our 2 points, and we can draw a line passing through those 2 points. And it's kind of a squiggly line, but it is a line passing through those 2 points. And so that gives us our line, and it gives us an understanding of what this equation looks like when you graph it. We could choose different values for x or different values for y, and certainly add to this in terms of getting more points or getting more rows of our t-table. So this form of line is a very common form in lots of different areas and lots of different branches of mathematics. And it's sometimes referred to as a general form or standard form. I've seen various names. The name really isn't important, but what is important is that the left-hand side of the equation has some coefficient times x, which is usually symbolized as ax, plus some coefficient times y, which is naturally usually symbolized with a b, so by. And now on the right, you have some number equal to c. And there's a special form of this where you sort of bring everything over to one side and you have a 0 on the right-hand side. But for now, this is sufficient. Ax plus by equals c. We'll see lots of examples of this form of the equation of a line.